Hi, this is Nathan Tintle. In this Learning Goal video, we are going to talk about how to state the null and alternative hypotheses when you're comparing two means. We will use the bicycling to work example to talk about this learning goal. In the bicycling to work data set, we're curious if there's evidence of a significant difference in the commute times based on the bike that Dr. Jeremy Groves rode. In other words, is there evidence of an association between the bike he rides, the explanatory variable, and the length of his commute, the response variable? Well, the structure we've seen other times is that the null hypothesis is a statement of no association, and the alternative hypothesis is a statement of association. So let's apply that to this data set. The null hypothesis would say there's no association between the bicycle Dr. Groves selects and his commute time, while the alternative hypothesis says that there is an association between the bike selected and commute time. Now remember, two variables are associated or related if the value of one variable gives you information about the other variable. When you're comparing two groups, this means that the average value of the response variable in the two different groups will be different if there is an association. Putting that in this context, the null hypothesis says that the long-run average commute time using the carbon frame bike is the same as the steel frame bike. The alternative hypothesis says that those two means are different, that the average commute time using the carbon frame bike is different than the steel frame bike. We can also write this in terms of symbols. Because we're talking about long-run averages here, we're using the Greek letter mu, and so you can say for your null hypothesis that mu of the carbon bike, the average commute time when he rides the carbon bike, is the same as that average value with the steel frame bike. The alternative hypothesis is that those two means are not the same. One word of caution, we've talked about this before, but remember, hypotheses are about populations or processes. They're not about the sample data. We're not talking about the 56 days worth of data that we have for Dr. Jeremy Groves. We're talking about what would happen in the long run if he continued riding that bike day in and day out.